Hey, hopefully everything is working. Uh, it says that my mic is on, so it should be working. Hello, everybody. Welcome to the finals live stream. I have my chat over here, that's why I'm looking this direction. So I have 10 to 15 example problems planned. We're basically just going to be going over algebra final exam review. So for those of you who are studying for your final exams, whether it's Algebra 1, Algebra 2, college algebra, intermediate algebra, fill in the blank algebra, this is going to help with those classes. And I think even if this seems a little bit easy for your class, I think that going over the fundamentals is super important. It's like the number one reason that I see people struggling with algebra. So this is going to be a really good review, I feel like. And we'll be going slow. Feel free to interrupt me and ask questions. Uh, whatever you guys want to do. I have problems planned, but if I don't get to them, that's totally fine. So here's the first problem. You can start thinking about this. Maybe even if you have pencil and paper with you, you can try to work it out on your own ahead of me. Or if you're watching the VOD afterwards, you could literally just pause the video and try it yourself first. That's always a good thing to try to do. Videos are single-handedly saving my ACT score. I just wanted you to know. Well, thanks. But it's mostly you. But yeah, I'm glad that I could help with that. Sitting down to work these out now. That's a good idea. Yep. You want to be trying to do practice problems on your own. Actually, there's going to be an ACT video in a couple weeks, I think, that I talk about this specifically. I'm like, you want to start by watching people do problems, but eventually you want to be able to try to do them on your own and maybe even in a timed environment. Maybe like I'm going to do 5 questions in 5 minutes and then just try it out. But that'll be for a video coming out soon-ish. But yeah, feel free to try these out yourself and follow along, or just watch if you don't want to put in the brain power right now. That's totally fine. So this first problem right here, we're going to be solving for x, but there's an x on both sides of the equation. So what do you guys think will be the first step? Because to get x by itself on one side, you have to get rid of one of the x's, right? Now, there's two of them that we can get rid of. We can get rid of the 5x or the 2x. And basically, because these are both being added, there's no minus sign. We remember that we always have to do things on both sides of the equation. So if we want to, for example, get rid of this 5x over here on the left, we would have to subtract 5x, but we would have to do it on both sides. And personally, I don't really like that because then we have 2 minus 5. Those are negative numbers. 2 minus 5 is going to give us a negative number, and I prefer to avoid those wherever possible. So I'm going to get rid of the 2x. I'm going to subtract 2x from both sides of the equation, right? So once we've done that, we can cancel these out. These are going to, the 2x minus 2x is just 0, so it's going to cancel itself out on this side of the equation. So on the right, all we have is a plus 8, so just positive 8. Now on the left side, we have 5x minus 2x. So the way you subtract this is just 5 minus 2. 5 minus 2 is 3, and the x is going to stay. And now we haven't done anything with this minus 4, right? So the minus 4 is going to stay the same. So hopefully this makes sense so far. And now we just need to solve for x, get x by itself. Remember that a letter in algebra is called a variable. Basically, it's a number that we don't know what it is yet. Think of it as a fill in the blank problem. If I said fill in the blank, 3 times blank minus 4 equals 8, then you just fill in the blank. That's what a variable is. So to get x by itself, we have to get rid of this 3, and we have to get rid of the minus 4. And remember that this is multiplication right here. Whenever you have a number and a letter next to each other, that means they're being multiplied, because apparently in math, we're too lazy to write multiplication signs. So I personally like to get rid of addition and subtraction first, because then if we're dividing everything by 3, we're dealing with fractions. So what's the opposite of minus? The opposite of minus is plus. So we need to add 4 to both sides of the equation. So the minus 4 and plus 4, those equal 0, so they cancel out. On the left side of the equation, we just have 3 times x. On the right side, we have 8 plus 4, which is 12. And now you'll see that we only have one number that's next to x that we have to worry about. So remember I said this is multiplication. Now the opposite of multiplication is division. So to get rid of the 3, we need to divide both sides by 3. Yo. So the 3's here cancel out. 3 divided by 3 is 1. And remember that a 1 next to a letter doesn't do anything. It's just an invisible 1, because anything times 1 is itself. So that just leaves us with x on the left side. On the right side, we have 12 divided by 3, which is 4, which means that our final answer is x is equal to 4. Can you go over trig functions after this? Sure. Yeah, I can go over those real quick. I know that some geometry classes they go over that. I don't know if you're taking trig or if you're taking geometry where you introduce trig a little bit, but yeah, it's a pretty important concept. So I'll go over that real quick. They actually had it in the algebra book that I was doing to go over my algebra full course. The book I was using had 2 whole chapters on trig. I was like, why is there so much of this in an algebra book? But I ended up not going over those because I was like, if I ever do a trig course, it'll be in there, obviously. I missed those days in class and never learned it. Yeah, it's one of those things that I feel like we learned it one random day, and it was just like, what even is this? I still didn't even really understand what it meant until I actually took trig, but it's important. Okay, but before I erase it, does everyone understand the purpose of solving for x? This might be the most important thing. The 2 most important things you need to know are solving for x and graphing a straight line, which I think we have a problem on that in a few minutes. Those are the 2 things you need to know how to do for algebra. Taking algebra 2 10th grade. Well, nice, you're doing it pretty early. So that's when you're learning the trig functions? I never learned it in algebra 2 for some reason. I feel like every class is just so different. But yeah, if some people are learning it in their algebra classes, then yeah, let's go over it for sure then. All right. Trig functions. So the 3 main trig functions, there's technically more, but the main ones are sine, cosine, and tangent. And we only write the first 3 letters because in math we are lazy and we don't like to put effort into things. So we're only going to write the first 3 letters. The full names would be sine with an E, cosine, and then tangent. But nobody writes those, so let's get rid of those. So the whole point of I'm burning my whiteboard up. Wow, all right, that was fast. Okay, so basically this is everything in trigonometry and ratios and everything else you learn is about right triangles. So if we have a right triangle, oh my gosh, this is awful. Okay, perfect. Yeah. Here's our right triangle, and we know that because it has a right angle, 90 degrees. And basically, the trig ratios are with reference to a certain angle. So let's say we have this angle here. Depending on your class, if they want you to start using weird Greek letters, then it might have, let's get green. They might have it as theta. And whenever you see theta, it's a Greek letter. It's basically just the same thing as x. It's just like an unknown amount, but specifically for angles. For angles, we use theta. Um, I'm not going to use Greek letters because, we've got English letters. So let's just say A, right? This is angle A right here. So basically the way that you can remember trig ratios, the class wants me, all right, we're using weird Greek letters. Here we go. Weird Greek letters. Theta. All right. So we're going to use theta for the angle. And essentially the way that I like to remember the trig ratios is by the acronym SOHCAHTOA. SOHCAHTOA. So each letter basically tells you what the trig ratios mean. Thank you so much. No problem. Yeah, we gotta complicate math wherever possible, right? We gotta scare people away by utilizing multiple different alphabets. Would this be considered algebra 1 or 2? This specifically, the trig ratios, I can't imagine this being an algebra 1. It's probably more of an algebra 2 thing. When we finish up the trig ratios, I'll go over stuff that will be in both Algebra 1 and 2. Those are going to be the first few problems. But we're just quickly going over trig ratios real quick. So the first three letters here, SOH, stands for sine is equal to opposite over hypotenuse. And then the next three letters stand for cosine is adjacent over hypotenuse. And then the TOA is tangent is opposite over adjacent. So let's say that this side was 3, this is 5, and this one's a little, we got to pretend that it's to scale, right? So we'll say this is 4 and this is 3. So these are your sides of the triangle, and here's the angle that we're talking about right here. So let's say we need to define the sine of this angle. You would see this written as, let's get these off here. So you would see this written as sine of theta. If it told you to find sine of theta, you would look at the triangle and see where's theta. Theta's right here. And we know that sine is equal to opposite over hypotenuse. Sure, what can I explain? If you're asking me to explain why we have trig ratios, the answer is I don't know. I mean, we use it for, because when I took trig, you can use it for things that aren't right triangles. You can like find missing sides of triangles and everything. As far as like real life applications, I don't know. You'd have to ask like an engineer or someone who knows more than me. Okay, so opposite over hypotenuse is sine, right? And you just remember that. It's just memorization. You remember it with SOHCAHTOA. So what's the opposite side? That's basically the side that's directly opposite of the angle that we're talking about. So because we're finding, explain SOHCAHTOA again. That's basically just how you remember the three trig ratios. So each letter stands for a word. So like each set of three letters, this is sine. This says sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. It's basically just like a method of remembering all of this information in just one sound. It's just a memorization trick. You don't have to remember SOHCAHTOA if you think you can just remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and etc. But usually it's easier to just remember one word. So is 3 over 5. For sine, yeah, it's going to be 3 over 5 because sometimes the answer is just because. Actually, almost all the time, it's just because. Especially like in algebra, a lot of it is just kind of you do it this way. Does it make sense? No, this is just how you do it. Just remember it. I personally like to try to learn why something works the way it does as much as possible. There are some things that just doesn't work, like the quadratic formula, for example. There's no way you're going to figure out how that works. I mean, maybe if you're like in a much higher level math class, but for the sake of algebra, just memorize the quadratic formula. But other things, I'm usually not a fan of memorizing formulas. I think it's better to just understand why it works. So yeah, so opposite is going to be the side that's opposite of our angle. In this case, directly opposite is going to be 3. So our opposite side is 3. And that's going to be over our hypotenuse. Now, the hypotenuse, it doesn't matter where our angle is, because the hypotenuse is always the longest side of a triangle. It's always the diagonal side as well. So it's also opposite of the right angle. So in this case, no matter if we were doing this angle or this angle, the hypotenuse is always going to be 5, always the longest side. So sine is equal to 3 over 5. We can do one more, just as an example. Let's do cosine of theta. That's going to be adjacent over hypotenuse. Now, the hypotenuse we already said was 5. And now adjacent, you've probably figured out by now, is the one that we haven't done yet. But in case you didn't know that, the adjacent is the one that's next to it. And technically, the 5 here is next to our angle. But that's already the hypotenuse. That's already taken. So we have to use the other one that's adjacent, the one that's next to it, which is 4. The adjacent is between right angle and the angle. Yeah, that's true. I didn't even think about that. Like, for example, if you were using this angle, the adjacent is 3, and it is, yeah, it's between the angle and the right angle. If you want to think of it like that, That also works. And then if you guys want to try to figure out what tangent is, I guess I'll do tangent real quick. Tangent is opposite over adjacent. Sorry, I'm taking up a ton of board space and it's looking messy. But the opposite is the one directly opposite of the angle, which is 3. And then the adjacent, as we just said, is the one that's next to it, not 5, because 5 is the hypotenuse, which is always the diagonal side and the longest side. So the adjacent is going to be 4. So that's how you find your trig ratios. Oh boy, we've got some trig formulas in the chat. I'm scared. But yeah, you can also find the same ratios for this other angle here, up here. Like for example, if theta was up here, it'll give you slightly different answers because now 3 is the adjacent and 4 is the opposite. What if tangent equals 4 over 3? Yeah, tangent would be 4 over 3 for this angle up here. For here, opposite is 4 and adjacent is 3. So that would actually give you 4 over 3. But it's the first time I've ever had anyone explain this in a way I've understood. Well, thank you. Yeah, it's with math, I feel like especially in a school setting, because you have to be teaching so many people at once, you kind of just have to assume that they know things already. And I try not to do that as much as possible because I feel like it's so easy to get lost. Um, just like if there's like one little thing that you get stuck on and the problem just keeps going, then like we're cooked is over, right? So I feel like that's why I always try to go slow, just explain everything as much as possible. And yeah, so that's trig ratios. Let me know if anyone else has any other questions about that. So I'm gonna go on to, and hopefully, assuming that this works, we should be able to go to, wow, the number changed, guys. Technology. What do I have for problem 2? Okay, here's another one that whether you're in Algebra 1 or Algebra 2 or college algebra or any algebra class, this is going to be really important. This one, we're going to have a little bit of distributive property action. And we're also going to be having an inequality here, right? This is not an equal sign. This is a less than sign. So we'll see if you guys can remember what to do in this scenario. Call me Jaden. Hi, Jaden. All right. So what do you do when you have the distributive property? Expand. Yeah, that is what I'm going to do. The other way you could do this, if you just hate the distributive property so much and you never want to see it again, then you can just divide this by 3, right? If you want to get rid of this 3, it's multiplication. So what you can do is you can just treat this as this whole thing as if it was just a letter by itself. And you can get it by itself by dividing both sides by 3. I'm not going to do it that way because I want to show you guys the distributive property because it's important. So what does the distributive property say? It says that if you want to multiply a number by a thing in parentheses where you've got multiple terms, and if you ever hear the word term, it's just a term is just a thing that's being added or subtracted. So this is a term and this is a term. They're two terms added together. So if you've got multiple of those in parentheses and you want to multiply, you have to multiply the 3 to both parts inside of the parentheses, right? So what's this first one here? 3 times -2. Well, 3 times 2 is 6. And we have one minus sign. The minus sign is going to stay. And we have an x here. Remember, the x, we're not doing anything with it because there's no letter over here. So it's just going to stay with an x. And then here we have 3 times 4. Now, if you had a minus sign here, then that's one of the most common mistakes is missing minus signs. So, but we don't have one here. So 3 times 4 is 12. It's going to be plus 12. And we haven't touched this part, so it's going to be less than 6. So that was the distributive property. Make sure you know how to do that. We're going to solve this now just like we did with our first problem. But there is going to be one thing that's different because of this less than sign. But we'll get to that when we get to that. Positive times negative equals negative. Yeah. So 2 positives multiplying together makes a positive number. Two negatives make a positive as well. And if one of them is negative, then it's going to be negative. So remember, I always like to get rid of addition and subtraction first. So let's get rid of this plus 12 by doing minus 12, the opposite of that, on both sides. So these cancel out. On the left side, we just have minus 6x. And on the right, we have 6 minus 12. Now, when I used to tutor people, people would get confused a lot about negative numbers. And if you've watched any of my videos, you're probably annoyed with me at this point talking about money so much. But basically, whenever we get negative numbers, I just think of it as money. So think of it as you just made $6 and then you spent 12. You are obviously down money. You're down $6. So it's going to be minus 6. If you're confused about negative numbers, just think of it as money. And now we just have a one-step equation. This is multiplication, the number's next to the letter. So we're going to do the opposite of that, which is division. Divide negative 6 on both sides. So the negative 6's cancel out. On the left, we just have x. And on the right, we have negative 6 divided by negative 6. Now, anything divided by itself is 1. So it's going to be 1. It's be 1. Okay. Now, what's different? What's different? What's different? Someone said it. No, you have to flip it. Yep. When do you have to flip it? We have to flip the inequality sign. So it's going to become greater than. We have to flip it whenever we multiply or divide by a negative number. So because we divided by negative 6, we have to flip the inequality sign. And I've had a few people ask, like, why do you have to do that? And I guess the way to think of it is think of 4 is bigger than 3. But once you put minus signs on both of them, this isn't true anymore, right? Now negative 3 is bigger than negative 4. So whenever you attach a minus sign on both sides, it actually has to flip the sign around. I don't know if that makes sense, but that's kind of how I like to think of it. It's just with like this kind of example here. Putting a minus sign on both sides of anything has to flip the the alligator around. If that's how you learned it back in elementary school, the alligator eating the bigger number. But yeah, x is greater than 1 is our answer. If you weren't sure, you can just plug in a number that's bigger than 1 back into the equation and then make sure it checks out. Chomp chomp, yes. That is the sound that that alligator makes. I'm surprised we're already at 16 viewers. I think because I did a few live streams last year, when the channel was kind of, I mean, it's still small, but like back when it was smaller. And I think the most it ever reached was 18. So we'll see if we can beat that. What about put in number line? Good question. I haven't done this in a while, but I think I went over it on my like one of my very first videos, and it's important. Let's do that real quick. X is greater than 1. X is greater than 1. And now you're going to witness me draw the world's worst number line. Can we just draw a line here? This might be easier. Okay. I'll save you guys the torture of watching me try to draw a number line. But we're still gonna have to put. Okay, we'll do this. Okay, so if you remember back from like elementary school, the point of the number line was to just show where a number is. So 1 is right here, negative 2 is right here. But in algebra, we take it a step further and we put entire inequalities on the number line because the answer to this is any number that's bigger than 1. And that is basically going to be anything that's to the right of 1, because to the right is bigger numbers. I don't know if this is to the right. Yeah, it's to the right. Okay. So it's to my left. So basically anything that's bigger than 1, like 2, 3, but also all of the decimals, 1.5, 2.5. So we're basically going to shade in this whole area here. And now remember that number lines go infinitely. Like this goes 4, 5, 6, 7, 8, 9, 10, etc. So we're going to put a little arrow here. This arrow, wow, this is okay. This arrow is going to show that it goes infinitely to the right. Any number that's bigger than 1 million, 1 billion, doesn't matter. Now, the one important thing here is 1 included in our answer? Like 1 exactly. And the answer to that is no, 1 is not, because 1 is not bigger than 1. 1 is exactly 1. So to show that 1 is not part of our answer, it's going right forever. Yep, it's just going to the right on into infinity. But 1 exactly is not part of our answer. We're going to put a little open circle. This open circle is showing that 1 is not part of the answer. But if you had like 1.0001, that's a little bit bigger than 1. So it's part of our answer. But 1 exactly is not. Now, 1 would be part of our answer if we had a greater than or equal to sign. This little line down here means that 1 is part of the answer. It can be bigger than 1 or equal to 1. And if this was the case, then we would have to close our circle to show that 1 is part of the answer. So I hope that makes sense. That's how you put inequalities on a number line. We use open parentheses. Yeah, that's another way to write it. I forget what it's called, like interval notation, I think. Like, for example, you could say, like, if we go back to this example, you could write it like this. I know this looks like coordinates, but this is basically saying that it goes from 1 all the way to infinity. And the parentheses mean that they're not part of the answer. Now, if we had equal to, this parentheses here would actually become a bracket. The bracket means it is part of the answer. And I know it looks a little weird that we have a bracket here and parentheses here, but it is correct because parentheses are around the infinity, because infinity is not a number. You're not going to have infinity as your answer. So it's not included in the answer. Okay, so that's how you put an inequality on a number line. Let me know if anyone has other questions about that. We're going to move on to question 3 with the magic number changer. Wow. Uh, okay. One more solving for x type problem. And then, oh, hold on. Okay. One more solving for x type problem, and then I think we have a graphing problem up next. Okay, so this is what's called a system of equations. That's where you have multiple equations in one problem, and that it also has multiple letters. So we have 2 equations and 2 letters. A simultaneous equation, is that what it's also called? I know there are so many things in math that I didn't even know had another name until I made a question about it, and then people were telling me. I hope you covered these. Yeah, these are really important as well. I say this is really important. This is really important. It's like, is it all really important? I guess it is. If it wasn't, I guess I wouldn't be doing it. Maybe. I don't know. Some of our later problems today might be a little bit like more obscure, but we're starting off with the things that are pretty much guaranteed to be on your test. So how do we solve this? There's like a bajillion different methods. The 2 main ones for an algebra class are substitution and elimination. Substitution is where you pick out an equation and try to get one of the letters by itself. And then you plug that into the other equation. It takes longer, but I feel like it might be easier to understand. The other one is elimination. I think it's usually faster, but it's a little harder to understand. So this one, I'm actually going to do substitution. And the reason is because getting a letter by itself seems kind of easy with the second equation. Can I try? Yeah, feel free to get a piece of paper and just try these out yourself and follow along. Try to get ahead of me. Um, that is probably one of the best ways to study, honestly. So let's take this second equation and try to get a letter by itself. We can get x or y, either one works. I'm going to get x by itself because y has a minus sign on it, and I don't want to deal with that. So to get x by itself, we need to get rid of this minus y. the opposite of minus is plus. So let's add y to both sides. And this is a pretty important thing in algebra. You want to get used to doing algebra with letters too, not just numbers. So these cancel out. On the left, we just have the letter x. On the right, we have negative 3 plus y. Technically, that's the same thing as y minus 3. So I'm actually going to write it as that. Y minus 3 here. It's getting kind of hot. Okay, so we've solved for x, but we don't know what number x is equal to because, like, we have a y here. We don't know what y is equal to either. But the way that we can do this is we can actually, I had no idea you could do that. Yeah, there's so many different ways to solve systems of equations. I think I've gone over like 4 of them in 4 different videos. 2 of them are garbage. It's a table and graphing, and no one would do it normally either way. Substitution and elimination are the 2 big ones. So yeah, so this equation up here, we have an x and a y. We want to just have one letter, but we know that x has to be the same as y minus 3. They're equal to each other. So if we just take this x, replace it with y minus 3, now all we have left is y on this top equation. So let's take this top equation here. I'm actually going to, just for our reference, I'm going to write x equals y minus 3 up here at the top, just so we don't forget. And erase this. So I'm going to rewrite this top equation, but instead of x, I'm going to write y minus 3. And I'm putting it in parentheses because it's multiplication. We don't want to think that it's 3y minus 3. It's 3 times everything. The rest of the equation is going to stay exactly the same as it was before. And now we have our good friend, the distributive property. So 3 is being multiplied to y minus 3. And we have to do it to both parts inside the parentheses. So is like sub in the, yeah, I mean, we're substituting in the whatever x is equal to. It's called substitution. And elimination, honestly, I like it better, but it's a little bit harder to explain. So I think I go over it in a few of my final exam videos, or I just have a video about it itself, but it's kind of old. And yeah, it's just an old video, but it should still be good. Okay, we're multiplying to the y and to the minus 3. So first, the 3 times the y, you can't multiply a number and a letter because we don't know what the letter is equal to. So it's just going to stay as 3y. Here we have 3 times negative 3. So 3 times 3 is 9, and we have 1 minus sign, so the minus sign stays. The rest of the equation is going to stay exactly the same because, well, we haven't done anything with it. Could you also go over exponents and logs? Because I think I have a question about that, but it's not until later. I might be able to just skip to it. Okay. I have an exponent question. I think I have it here at number 8. Let's actually do that one next. After this, let's do the exponent question. Okay. So now you might notice here that all we have left in this equation is y, the letter y. So this one here and this one here, we can actually combine these because they both have the letter y. They're like terms, so we can add them together. Now this minus sign is not going to come into play for this because that's attached to the 9. So we just have 3y plus 2y, which is 5y. Now we haven't done anything with the minus 9, and we haven't done anything with the minus 4. And now continuing to get y by itself, let's get rid of the minus first by doing plus. Plus 9 on both sides. So these cancel out. On the left side, we just have 5y. And on the right side, we have negative 4 plus 9. So remember that you can just flip the order around. So that's the same thing as 9 minus 4, which is 5. I'm going to move this up here. This is multiplication. Multiplication. So I'm going to do the opposite of that, which is division. divide both sides by 5. These cancel out. On the left side, we just have y. And on the right, we have 5 divided by 5, which is 1. So y is equal to 1. Let me know if anyone got lost on that, because I don't want to go too fast, but this is like the same thing as what we were doing earlier. But I still want to try to go slow for everybody. But that's not the whole problem, because we just solved for y. Remember, we have to solve for x and y. That is our goal in this problem. So here I'm going to put y equals 1, and I'm going to erase everything. You can rewind if you still need it. I just want to make room for this final part. So basically, we just need to solve for x now. And using the same principle, we know that y is equal to 1. They're the same thing. So we can replace y with 1. And I think I want to do that on this bottom equation. We can use either equation, but I want to use the bottom one because x is closer to being by itself. So let's rewrite this bottom equation, but instead of y, we're going to write 1 because we know that they're the same thing. And now we just solve for x. So to get x by itself, we get rid of this minus 1 by doing plus 1 on both sides. You literally answer my questions as I type them. Well, I'm sorry. I'm sorry for doing that. Yeah, okay. So these cancel out. On the left, we just have x. And on the right, we have negative 3 plus 1. And I'm going to be the annoying guy that's like, think of it as money. You lost $3. You gained 1 back, but you're still down $2. So our answer is minus 2. What about using first equation? Yeah, you would do it the same way. So you could just take y here and replace it with 1. So like 2 times 1, and just solve it like that. I just didn't do that because it takes longer. That takes, sounds like a bad day. Yeah, using the top equation is just a little bit less fun because there's more steps. We got to get rid of the 3 as well, and it just accomplishes the same thing. But you could if you really wanted to. If you're like a big algebra fan, you want to do more steps, then you can. But either way is correct. They just accomplish the same thing. So x is equal to minus 2, and that is the other part of our answer. And as always, you could check your work, plug in negative 2 for x, 1 for y, and make sure both equations are correct. Personally, I think that takes a long time, so I'm not going to do that. One other thing I want to mention is that there's another way to write your answer that your teacher or professor might want you to do, and that is by using coordinates. So you know how when you have coordinates on a graph, it goes x and then y, right? So you would just write it the same way. X is negative 2 and y is 1. You could write your answer like this as well. I don't know how common that is, but I think it's sort of common, so I thought I'd just bring it up. So that is how you solve a system of equations. And if you, I would definitely practice that. I think it's like basically guaranteed to be on your test if you're taking your algebra final soon, or if you're taking the SAT or ACT. I think it's usually on there as well. Okay. Well, next I have a graphing problem, but I said I would skip to exponents. And I think these are important. Hopefully, this is what you, the person in the chat, wanted to go over this kind of problem. Hopefully, this helps you, and hopefully, it helps everyone else. I was already going to do this problem, but we'll just do it sooner. So basically, this is another solve for x problem, but x is going to be trapped inside of an exponent. Like that. There we go. See the answers to systems of equations as coordinates more often than not. Yeah, that's true because each of those equations is also a line. You could graph it on a graph. You could graph the line. And like if you put it in Desmos, then the answer, this is a big SAT or ACT trick. If you're taking that test soon, when you're using Desmos, if you put a system of equations into Desmos, you're going to get the 2 lines that cross. And the point that they cross at is going to be coordinates. And that's actually your answer. So That is a good trick if you don't want to have to deal with solving systems of equations, but just specifically for the SAT or ACT. Will you make a video about calculator tricks with final exams on paper? I should. I haven't even thought about that. Um, but I mean, probably not soon, just because like school and work stuff going on. It's probably too late to do a video on that like right now. But I know that for the ACT, some people are taking that on paper, and people are like talking about how OP Desmos is. Like, oh my gosh, Desmos on the SAT. But like a graphing calculator, just a regular one, does the same thing, pretty much. I mean, it takes longer, but it has the same stuff. Make the base same so we cancel out. Anytime I get a problem like this, I pick a random question. Okay. So how do we solve for x in this equation here? Well, I mean, it's not too easy because they're kind of trapped, and I think the person said you can use a logarithm. I believe you can do that. But I think the easiest way to think about this is to just make the bases the same. So here's a little illustration for you. I want you to imagine this same problem, except that instead of a 9, we have a 3. 3 on both sides. Well, if you wanted to solve for x, we know that the bases are the same. 3 to the something equals 3 to the something. That something is going to have to be exactly the same on both sides, because 3 to the 4 is not going to be 3 to the 5. That doesn't make any sense. We know that the exponents would have to be the same. And so we could just completely ignore these 3's and do x plus 2 equals x minus 2, and then just solve for x. So that is like the perfect scenario. Unfortunately, we don't have that perfect scenario, but we can make it our perfect scenario. So pick a random answer. Yeah, that's one of the things. Like, oh, you mean like when you pick a number and then just test it out? That works sometimes. I probably did that a lot because like in like high school and stuff, I did like math competition things for a little bit. And if I didn't know how to do something, just plug in numbers and see if it works. Yeah. Okay. So let's try to get these two bases to be the same. The bases are just the big numbers. Now, the way we can do that is with some exponent tricks. So because obviously the question writers, they want to make it as simple as possible for the person, or they want to make it complicated, but they want it to be possible to do. And I may notice that 9 is 3 squared. 9 is 3 times 3. Squaring just means multiplying by itself. So what if we just rewrote the equation, but instead of 9, we wrote it as 3 to the power of 2, 3 squared? Well, now we can do an exponent trick, because right here we have a power of a power. And whenever you have an exponent in an exponent, you can just multiply the exponents together. So the left side is going to stay the same. On the right here, we multiply the exponents together. We have 2 times x minus 2. And if you've been watching, you're going to be like, that's the distributive property. And I'll be like, that's absolutely correct, because we have a number times x minus 2. 2 times x minus 2. This is the distributive property. So how do we solve this? We multiply the 2 to the x and to the minus 2. So 2 times x, we can't multiply those. That's going to stay as 2 times x. And on the right, we have 2 times negative 2. So 2 times 2 is 4. And we have 1 minus sign, so the minus sign stays. So 2x minus 4. That is going to be our new exponent on our number on the right. Actually, I won't erase that yet, just for anyone who's following along. So now we have our magic scenario where the two big numbers are exactly the same. So we can just ignore those. I won't cross those out. We'll just take the two exponents because we know they have to be equal to each other, like this. And now we just have a solve for x problem, right? So I can get rid of the x or the 2x. I'm going to get rid of the x first to avoid negative numbers, because I don't want to subtract 2x like this, because then we have negative numbers and nobody likes that. So let's get rid of the x. I'm going to do minus x on both sides. So these cancel out. On the left, we just have 2. On the right, we have 2x minus x. Now, x is the same as 1x, so 2 minus 1 is 1. So that's 1x. But you don't have to write a 1. 1 times anything is itself. So it's just going to be x. And we haven't done anything with the minus 4, so it's going to stay as minus 4. Let's move this up here, if that's okay. How would I look up a worksheet for this? I think if you search like exponential equations, then you might be able to find it. I think I have a video on it. It has like 2 problems, probably. But yeah, if you want to look it up, try searching exponential equations and see if you can find something like this, where x is trapped in an exponent. And now our last step to solve for x is get rid of this minus 4. So I'm going to do plus 4 on both sides, because that's the opposite of minus. So these cancel out. On the right side, we have x. And on the left, we have 2 plus 4, which is 6. I think someone got it in the chat. Yes. X equals 6. So that is how you solve for x when it's in an exponent. An x in an exponent. It's trapped in there. That's how you solve it. You try to get the bases the same if they aren't already. If they are already the same, then it's just your lucky day, I guess. But if they're not, then you have to try to make them the same. Sometimes you even have to do it on both sides. Like you would have to do an exponent thingy on both sides of the equation to try to get the bases the same. Hopefully your teachers aren't that mean, but it's possible. It is possible. All right. Hopefully everyone understands. You can always rewind if you need more help, or after the stream, you can do some practice problems. I would highly recommend. Let's move on to some graphing, because being able to graph for algebra is super important. So go like that. Problem number 5. And I'm going to switch to the graph board in just a second. And as always, if anyone has any questions, feel free to drop them in the chat, and I will do my best to answer them. Okay. So this one, we're going to be graphing a straight. Yeah, we're going to be graphing a straight line. We need to graph two. Let's decrease the size of this. Okay. 2x equals 3y plus 3. We need to graph this line. How do we do this? Because normally when we graph a line, we want it to be in something called slope-intercept form. The slope-intercept form is y equals mx plus b. And I've always got to make the obligatory joke. The m stands for the slope, and the b stands for the y-intercept. Don't ask me who chose those letters. I don't know. It wasn't me. Some people remember it as y equals mx plus c, or I've heard, yeah, y equals ax plus b is another one. Just, yeah, there's so many different ways to do it, but they all are the same thing. They just use different letters. And honestly, the letters don't even matter, because apparently we have to use m for slope, and whoever decided m, I don't know. But that's what we'll be doing for this. Now, in y equals mx plus b, y is by itself. That's the key thing. And y is not by itself in this equation. So we can't use that right now unless we can get y by itself using our algebra skills that we've built up over the past 53 minutes. So let's go ahead and, is there anywhere convenient I can put this? Not really. I'll put it right here for now. The goal is to get y by itself. So how do we do that? We have to get rid of this 3 and this 3. I have a real talent for mangling these equations. Good, yeah. I mean, just being able to move letters and numbers around and stuff is basically the bulk of algebra. So once you have that down, you've got like 80% of algebra down. And then maybe 19% is graphing, and then 1% is the other random things you have to know. So I'm going to get rid of the addition first. I like to get rid of that first. The opposite of plus is minus, so let's subtract 3 from both sides. These cancel out. On the right side, we have 3y. And on the left side, we have 2x minus 3. These are not like terms. This one here has an x, this one doesn't. So we can't add them together, or subtract them, I guess. So it's going to stay as 2x minus 3. And just because we're trying to get y by itself, right? And I don't want, because y is on the left and it confuses me when y is on the right. So let's actually just swap these around, if it'll let me. It won't. Okay. Uh, we'll do it at the end. We'll do it at the end. So the 3 is being multiplied to y. I'm going to do the opposite of multiplication, which is division. But remember that you have to divide everything by 3 on the other side. So here, this is just going to be y once we cancel out 3's. On the left, we have to divide the 2x by 3 and the negative 3 by 3. Everything by 3. And this is why I hate fractions and solving for x. That's why I avoid them as much as possible. But sometimes you just can't. Sometimes you just can't avoid them. So 2 divided by 3 is not simplifiable. That's just a fraction. So it's going to stay as 2x. Well, 2x over 3, you can also write this as 2 over 3x. And I think that'll be easier to understand as we go into slope-intercept form. And then here we have 3 over 3, which is 1. And I forgot that's a minus. Probably the number one mistake in algebra. I feel like everyone does it at some point. But yeah, minus 1. That is a weird minus sign. Minus 1. So now, as I was saying, I like to have y on the left side, and you can just swap the two sides of the equation around if it makes you happier. It makes me happier for sure. We can just do that. Just keep y on the left side, and then that way we can compare this to slope-intercept form a little bit better. So how do we do this now? What is the slope and what is the y-intercept? Well, the slope is the number that's next to x, just like in y equals mx plus b. And in this case, that's 2 over 3. So our slope is going to be 2 over 3. Our y-intercept is going to be b, the number by itself. But it's not going to be 1. It's going to be minus 1. Because here it says plus b. But this says minus 1. Remember that minus is just the same thing as adding a negative number. Whenever you get confused about negatives and all that, just think of it like that. Subtracting is just adding a negative number. So our y-intercept is negative 1. I'm going to leave it like that for now, but it's the same thing. So it was only dividing 3 and not, yeah, that's another common mistake. You don't want to just divide one part of it, because like if you just divide the 3, well, why don't you also just divide the 2x? Like which one do you divide? Well, the answer is all of it, right? And that's why I hate the dividing stuff so much. Hydration break. Okay, so let's graph our y-intercept first. Right here. -1 is our y-intercept. The y-intercept of a graph, and this is important, it's where it crosses the y-axis. The y-axis is this big vertical line here, up and down. The x-axis is the left and right. That's good to know. Sometimes it'll just tell you x and y, but in case it doesn't tell you that, it's good to know. X is left and right, y is up and down. The y-intercept is -1. So starting in the middle, negative numbers or positive numbers go up and negative numbers go down. Like this is 1, 2, 3. If we had numbers on here, this would be -1, -2, -3. So -1 means we need to go one square downward. We need to go one square like this. And right here is going to be where it crosses the y-axis. That is our y-intercept. Let me know if that makes sense. If anyone has any questions, let me know. Here we have our slope. And the slope is going to be important because when we graph a line, we can't just do one point, because if we only had one point, well, it is the line like this, or this, or this. I mean, that was terrible, but just anything that crosses the point. If we just had one more point, we could connect the 2 points and we would know exactly where our line is. So the way we can find another point is by using the slope. So slope is equal to rise over run. This is another formula that's good to know. The slope formula, rise over run. Now, because our slope is 2 over 3, this means that our rise is 2 and our run is 3. So we have to start at our point right here that we just had earlier, and we start with the rise. So rise is 2. That means we need to rise 1, 2 squares. And now the run is 3, which means it means we need to run 1, 2, 3 squares. And now right here is going to be another point right there. Now we could do that again. We could go 1, 2, 1, 2, 3, have another point, but that just takes too much time. We can do it with just 2 points. Once you have 2 points, that's it. That's all you need. So now just cleaning up this stuff. The last step here is to just draw a line that connects the 2 dots. And hopefully your line is going to be a lot neater than mine because I can't draw. I mean, I guess it wasn't that bad, but yeah. And I know that there is a straight line drawing tool on this whiteboard, but that's just boring, you know? I want to try to draw the line myself. Got to do it ourselves and be good artists. So, oh, I just now realized that my head is blocking this a little bit. Yeah, right here, y equals 2/3 x minus 1 is the equation. Sorry for blocking it a little bit with my head. Um, yeah, because I can only see my head if I look over here. Uh, yeah, this is right here is the whiteboard. So let me know if anyone has any questions about that. We're going to do one more graphing problem here. This one is going to be a little bit more complicated, but I think it's pretty important, both for Algebra 1 and 2, and college algebra, and any other algebra class. I think this was one of those things, because there are a lot of things that I learned in Algebra 1, and then we like reviewed in Algebra 2. I feel like this was one of those things. Know this trick. What trick? What trick did you learn? We need to know. We like good math tricks here. Rise over run. Yeah. Because I know another way that you can get a point on the line is you can just plug in numbers for X and then get other ones out for Y. You could do that too, but I feel like that takes longer. And then sometimes you get decimals or fractions, and then it's harder to graph. It's a little bit less accurate. I think the most accurate way, especially when you have like fraction slopes, is to do rise over run. I think that's the most accurate way if you're like graphing it on paper, for example. Or sometimes if you're graphing it on like on an online math thing, it'll force you to place your points on these corners. Like it wouldn't let you do a fraction exponent or a fraction amount. Okay, how do we graph this? This one has a squared in it. And we can't put this into slope-intercept form because that only works for straight lines. So because we have an exponent on x, or I mean, sort of on x, it's the exponent is applying to x and this, then we're not going to be able to get this into slope-intercept form because this isn't going to be a straight line. It's probably going to be a parabola. Parabolas are these U-shaped graphs, like this, for example, or they can be upside down. And essentially, that's what we're going to be graphing. Now, you could do this the way I just mentioned, which is you plug in numbers for X and then you get other numbers out for Y. But I don't want to do that. That takes a long time. So instead, we can use something called transformations. Lame. Uh, so yeah, transformations are basically where you take a parent graph, and the idea is that you don't put a ton of brain power into making the parent graph. You just do it the same way every time. So this is something that is going to take a little bit of practice. But once you have that down, all you have to do is graph the parent graph and then figure out what the extra numbers are doing. So for example, y equals x squared is a common parent graph, or y equals the absolute value of x, or y equals the square root of x, or even just y equals x could also be considered a parent graph. And yeah, so these are basically just the graph, getting it as simple as possible so that you graph it the same way every time. And in this case, which parent graph are we going to be using? Well, we're going to be using y equals x squared because there's a squared on x. So we use y equals x squared. Now I'm going to show you how we get the graph of y equals x squared, but this should be something that once you do it over and over, it's like the same thing. You don't do it differently ever. So just as an example here, if we plug in 0 for x, not not you, the exponent. Yeah, the exponent is pretty lame. I mean, I guess I'm kind of lame too, but the exponent is lamer. I agree. Okay, so we plug in 0 for x, and when we do that, we get 0 squared. That's 0 multiplied by itself. 0 times 0 is still 0. Put a random dot somewhere, I guess. So when we put in 0 for x, we get 0 for y. That's just the center of the graph. We're not going up or down at all. Now, if we plugged in, I like this, although it's very, yeah, whenever I do these kinds of problems on the final exam videos, it ends up taking the longest, I feel like. They're like the longest problems. So, uh, so buckle in, get your popcorn. If you eat popcorn to math videos, if that's your thing. I mean, you could eat popcorn for anything. If we plug in 1 for x, that's 1 squared. 1 times 1 is 1. So when we plug in 1 for x, we get 1 for y. Now, this is going to require you to know how to plot points. If you don't know how to do this, this is really important. Make sure you know how to do it. X is left and right, and positive numbers go to the right, negative numbers go to the left. So when x is 1, that means we go 1 square to the right. And now y is 1, y is up and down, and positive numbers go up, negative numbers go down. So when 1 is positive 1 for y, that means we need to go 1 square upward. And we're going to put a point right here. Hopefully this makes sense so far. Remember that this is the same thing every time, so you're not going to have to go through this whole thought process every time once you do it a few times. 2 for x, 2 squared, 2 times 2 is 4. So 2 for x means we go 2 squares to the right and 4 squares up. And you'll see that our kind of like U-shaped graph is already starting to form, right? It's kind of like exponentially going up like this. We have to do the left side now, though. And those are negative numbers over here, x being -1 and -2. So -1 multiplied by itself. Remember that two negatives make a positive. So -1 multiplied by -1 is +1. So -1 for x is left and right. And negative numbers go to the left. So 1 squared to the left, and then y is 1, so 1 square upward. Point right here. And now just to do one more, x is -2, y is -2 times -2, which is +4, because two negatives make a positive. So 2 squares to the left, 4 squares up. So this is where whenever you're graphing, take back my lame, I had no idea you could graph these by hand. This is cool. Yeah, I feel like so many, I don't know, I feel like graphing calculators and Desmos and stuff is becoming more of like the normal thing to do. But it loses its charm, you know? I mean, if you consider math charming, which most people don't, and will think that I'm just crazy. But this is how you can graph parabolas by hand. Uh, yeah. So we're gonna go ahead and just draw our little U-shaped graph. Like, oh no. You see, what you don't see in the videos is that I take like 17 tries to. Here we go. That's good enough. We're not taking that back. Okay. So this is how you graph it every time. Just remember 0, 0, 1, 1, 2, 4, and then 1, 1, 2, 4 on the other side. You could do it in like 5 seconds if you just memorize that. But it's good to know why we're doing it that way. I don't want you to just memorize something for the sake of it, unless it's like literally impossible to understand, like the quadratic formula. This is something that you can understand why it is that we do a U-shaped graph like this. So now the point of the problem, the transformations, I know you guys are like, what, when does this problem ever end? Are we like just starting? Yeah, we kind of are. We need to figure out what is this 3 doing to the graph? What is this -2 doing to the graph? Those are the only things that are different. I mean, yes, we have parentheses, but that's part of the -2. We have x squared. All we did was slap a -2 in the parentheses and then slap a 3 in the front. So we just need to figure out what those are doing to the graph. Once we figure that out, we can just do it to this graph instead of having to regraph everything. I think the -2 is easier, so let's do that first. Now, if you had a number on the outside of the parentheses, like just attached to the end, if we put a +1 here, for example, then what you're doing is you're taking whatever y is equal to and you're adding 1. Y is up and down, and positive numbers go up. So adding a +1 to the end is going to move the entire graph 1 square upward. Or if it was a minus, it would move it downward. But in this case, we actually have it on the inside of the parentheses. It's actually going to be affecting x, and x is left and right. So now you might be saying, okay, well, negative numbers go to the left. I know I just taught you that, but with transformations, left and right is the opposite of what you might think. Yeah, you could expand it out as a quadratic if you wanted to. You could do it that way, but I think that takes even longer. Like graphing a quadratic can be an even longer process than perhaps. But that is another way to do it. So this -2, so left and right, is the opposite of what you think. Positive numbers are going to move you to the left. Negative numbers are going to move you to the right. If you want to know why, I don't even know. I think I explained it in like on my video about this. I don't even know if I explained it that well. It's just one of those things you just need to know. Left and right is opposite of what you think. So negative numbers normally are to the left, but for transformation purposes, it's to the right. And it's a 2. So we got to move 2 squares to the right. Now, we usually do everything from the vertex, which is kind of like the center of the graph, the anchor point. So we're just going to move it here. And if we want, just to show you guys, I'll do it in purple. We can regraph everything. So every point is just going to move 2 squares to the left, or to the right, not the left. That and there. And now my terrible graph here. Okay. And we don't need the parent graph anymore. So right here is our new graph with the -2. We have not touched the 3 yet. We haven't talked about that. We need to figure out what the 3 is doing to the graph. Now, remember that this is multiplication. We don't have a sign in between the number and the parentheses. And multiplication means that we're multiplying whatever y is equal to by 3. So this point here is at y equals 0, right? It's not up or down at all. So it's not going to change. Actually, even if this was a square higher, it's still not going to change. The vertex is never going to change. But each other point is going to be multiplied by 3. So to get to this point, we had to go 1 square upward. But multiplying that by 3, we now have to go 3 squares upward. So the vertex is going to stay here. And then this point is going to go up by 3. And remember that parabolas are always symmetrical. So this point here that we had to move 1 square upward to get to, we're now going to move 3 squares upward as well. It's going to go right here. Now this one up here, we had to move 4 squares upward. And 4 times 3 is 12. So we have to move 12 squares upward, but that's off the screen. So we're not going to do that. It's off the screen. That's how high up it is. Because this is 4 squares higher than the vertex. 4 times 3 is 12. It's going to go way off. So just with these points, we're just going to do the best we can to be as accurate as possible. And we're going to just kind of try to draw a U shape. Just to the best of our abilities. Color coding these notes right now. Good idea. I usually try to do the parent graph in for these problems, I do the parent graph in green. And then I want the final answer to be in black. So that's why I usually use purple for anything in between, just because I don't want to confuse people and make them think that that's the final answer. Even because the highest I went was AP calculus, I think. And even the students there, like after every problem, we'd be in the middle of the problem and they'd be like, was that the final answer? So is that the final answer now? It's like, we don't even know when the answer is. So I don't want to confuse people like that. I want to make sure you know what it is we're looking for. And in this case, that is the graph of y equals 3 times x minus 2 squared. And this is the final graph right here. So I know that was a lot, but this is one of those things that takes a while to explain. But once you get it, it becomes really fast because the parent graph was like half of that problem. And that you can just do that like in your sleep once you do it a few times. Once you get used to it, obviously it takes practice, but then you can just be like, okay, 0, 0, 1, 1, 2, 4, 1, 1, 2, 4, U shape, right? And that's your parent graph every time for squared problems. So hopefully that made sense. I think hopefully the next problem doesn't take that long. Uh, okay, this one won't be too bad. Let's go back to the regular whiteboard, and we're gonna do another solving for x problem. We're gonna get into quadratics. This is another really important thing to know how to do. A little secret of recording these little dashes here. This is how I line up the screen because this isn't the entire screen, so I want to make sure that nothing's cut off. Okay, because we have to do the obligatory number change. Let's change it to 7, just so we feel like we're making progress. Okay, so this one is going to be a quadratic equation. And we are going to solve it. Oh boy, now we got to make this a thicker marker. Okay, we're finally going to write it. X squared minus 3x plus 28 equals 0. And our goal here is to solve for x. So how will we do it? And you might think, okay, we just solve it the normal way. We try to get x by itself. But we can't do it like that because x squared and 3x are not like terms. Like terms have to have the same letter and the same exponent. So these are never going to be able to be combined. And that means we're just stuck, right? We're never going to get x by itself. So we have to use one of our special methods, and there's like a bunch of these. The easiest, in my opinion, is factoring. It's the fastest and easiest. But factoring doesn't always work. Sometimes it's not going to work. The other ones that always work, as far as I know, are big numbers that multiply to 20 and add to 3. You're close. You're really close. And I'll explain why that's a little bit off. I'll just tell you. It's not 3, it's going to be -3. The minus signs always stay. They're part of the numbers for any algebra problem, not just quadratics. You never want to forget the negative numbers. But yeah, that's how we do it. That's how we factor. Yeah. It's like one of those things that you do the problem and then you're like, what did I do wrong? It's like, well, oh, I missed a minus sign. It's like the most common thing. It's so annoying sometimes with like just any math problem. You do all these steps and you're like, oh, I missed the minus sign earlier. And you have to redo the whole thing. The pain of mathematics. But yeah, factoring is the easiest. We're going to do it that way because I wrote the problem to make sure that factoring worked. If it didn't work, you could use completing the square. I personally don't really like it. I mean, it's cool, but it's not my favorite. Or the quadratic formula. The quadratic formula always works, even if you have like imaginary answers. If you have problems with imaginary numbers as answers, I think I talk about that in the quadratic formula video. But yeah, we're going to do factoring. So the goal of factoring is to get two sets of parentheses to equal 0. They're both going to have x, and they're each going to have x plus a number or x minus a number. Like, for example, x plus 2 times x minus 4. So to figure out those magic numbers, we have to find two numbers that add up to -3, and multiply to get positive 28. Add up to the number next to x, multiply to the number by itself. So even if this was out of order, you could put it in order and do this, or you could just leave it out of order and just know it's the number next to x that you're adding, the number by itself you're multiplying. So let's find two numbers. I like to start with numbers that multiply to 28. Wait, hold on, there might be an issue with this problem. Wow, okay. All right, me just being dumb, I guess. This is a minus sign, guys. This is not a plus sign. Factoring would not have been possible, I don't think. Sorry if anyone was going ahead. I think when I wrote the problem, I meant for it to be a minus sign, and then I copied it down as a plus sign when I was writing it down. So this is a minus sign. So we have to find numbers that multiply to -28. Sorry if that confused anyone. So I like to start with two. I like to start with two numbers that multiply to the number, and then I just see if they add to it. So let's find two numbers that multiply to 20 or to -28. I usually ignore the minus sign to start. Numbers that multiply to 28, the obvious one is 1 times 28. And now, because it multiplies to -28, one of these has to be a negative. And because we're adding to a negative number, I know that the negative has to go on the larger number because the negative has to be on the larger number for it to add to a negative. You're not going to have like -2 and +4 and then it adds to a negative number, right? The negative has to be on the bigger number. So these two multiply to -28. But if we add them together, 1 minus 28, you can use your money example if you want. You got $1 and then lost 28, you're down 27. -27 is nowhere close to -3. That is what we're looking for, right? -3. So this is not going to be correct here. What other numbers multiply to 28? Well, there's 2 times 14. And remember that the minus is going to go on the larger number because we're adding to a negative number. I don't think this is going to be correct, but it's going to put us closer. 2 minus 14 is -12. No, that's not correct because we're looking for -3. I think there's only one other one. Yeah, right there, 4 times -7. Yeah, 4 times 7 is 28. We put the minus on the larger number because we're adding to -3. And 4 minus 7, you gain $4 and then spent 7, so you're down 3. And that is the number we're looking for, right? -3. So that means that 4 and -7 are going to be our magical numbers that we use to factor this equation. So let's bring back our sets of parentheses. Put x on both sides. We're just going to insert these numbers. So 4 is positive, so we're going to put a +4. And then -7 means we're going to put a -7. And so these are the numbers. Let me make that a better 7. These are the numbers that we're going to put inside of our parentheses. So we've successfully factored, and if the problem said just factor it, then we factored it. Congratulations. But remember that our goal here is to solve for x. So how do we do that? What is the point of factoring this? Well, our first instinct might be to do FOIL, because FOIL is how you multiply these. But if you multiply these two together, you're just going to get this again. The whole point of this was to unfoil it, to put it into its factored form, like unsimplify. So that's not what we want to do. Instead, we want to do something special just because this is equal to 0. So because it's equal to 0, remember that in math, anything times 0 is 0. So if these are two numbers, because remember that this does not have a sign in between, so this is multiplication. These are being multiplied together. If x plus 4 is equal to 0, then it does not matter what x minus 7 is. 0 times whatever is 0. Or if x minus 7 is 0, it does not matter what x plus 4 is, because whatever it is, it's going to be multiplied by 0 and equal 0. So there are two instances where this equation is true. If x plus 4 is 0, the whole thing is 0. If x minus 7 is 0, the whole thing is 0, right? So we can actually split this up into two different equations just because of that, because it's equal to 0. If it wasn't equal to 0, you wouldn't be able to do this. That would not be allowed. So basically, you'll notice that we need to solve for x on both sides, on the x plus 4 and the x minus 7. And this is going to actually give us two different answers. And that's the point. Quadratic equations always have, not always, most of the time they have two answers. Sometimes they'll only have one, sometimes they'll have 0. But usually quadratic equations have two answers. So let's go ahead and solve this one right here. X plus 4 equals 0. I'm going to do the opposite of plus 4, which is minus 4 on both sides. So these cancel out. On the left side, we just have x. And on the right, we have 0 minus 4. The 0 isn't doing anything, so it's just going to be minus 4. And this is one of our answers right here. Now, what about the other one? X minus 7 equals 0. Well, the opposite of minus 7 is plus 7, so let's do that on both sides. So these cancel out. On the left side, we have x. And on the right side, we have 0 plus 7, which is 7. So x is equal to 7. Now, you don't want to say, like, which one of these is the answer. It's both of them. They're both the answer. If you plugged in negative 4 in for x on this equation, you'll get 0. And if you plugged in 7, you would also get 0. Now, one more way, I thought the degree determines how many it's plugged. Yep, it does. So a quadratic, that's why the signs changed. Yep. So a quadratic equation is basically any equation where you have an x squared as the highest exponent. And then you have, usually it has an x squared and then an x and then a number by itself. So that's what quadratic means. And you're like, but quadratic, the word quad means 4. I don't know. I think I actually looked it up one time. It's just like, it just means like I think the quad could also mean square. And that's why it's called that. I don't know. But yeah, math terms are all confusing. We got to make them as complicated as possible. But yeah, quadratic equation is x squared. Now, if you had an x cubed on here, like x cubed, then it could have 3 answers. So that's what degree means. The degree is the highest exponent, and the highest exponent determines how many answers you can have. So if your highest exponent is 8, then I believe that means you can have 8 answers to the question. And then this person, okay, so that's why the signs changed. Yeah, the signs changed because you might think that because we got 4 and negative 7, that those are our answers. But it's actually flipped. 4 and negative 7 become negative 4 and positive 7 because of this splitting up process. They actually end up being the opposite. So if you want to just take the shortcut and just go from here to straight to here, just changing the sign, you could. But that only really applies if there's not a number in front of x. Like if you had a 2 here in front of x, it would be a little more complicated. And I do have a video about that if you're interested, if you know that's going to be on your test. It's a little bit more complicated version of factoring. What did you say about the degree? The degree is the largest exponent. So if you had x to the 10th plus x to the 4th minus 2x to the 3rd, for example, the degree is 10. It's just whatever the biggest exponent is. And the biggest exponent, the degree, determines how many answers your equation can have. If your degree is 10, you could have 10 answers. If your degree is 6, you could have 6 answers. So that's why quadratic equations always have 2 answers, or most of the time. Usually they have 2 answers because the degree is 2. 2 is the largest exponent. If you draw this on a graph, you will see, yep. So if you were to draw this on a graph, for example, pretend this is a beautiful graph. Remember, it's a U-shaped graph. The answers are always where it crosses the x-axis. So you have an answer here and an answer here. That's 2 answers. So, for example, you could have one answer if it was like this, just directly on it once. And if it was like this, it's not crossing it at all, so that's zero answers. Just a little side note if you need to know how to graph these and how that works. It's where it crosses the x-axis for your answers. Those are also called zeros. Those are also called solutions. All sorts of names for like the same thing. Okay, I believe we can do like three more problems. Unless anyone has other questions. This is so helpful. I'm glad to hear it's helpful. Yeah, I'm trying to just go over what is probably most likely to be on your test. So, yeah, thanks. Oh, okay. All right. Solving for x, because solving for x is so popular. But this one is going to have a square root. Oh no. Can you do the quadratic formula? Yes, I can. Let's do that real quick. That's a good idea. Will it let me go back? Yes, it will. Okay, perfect. Let's do the quadratic formula real quick. So the quadratic formula, I do not recommend memorizing. Or no, I do recommend memorizing. Sorry, I normally don't recommend memorizing things, but this is one of those that you're not going to be able to understand. So just remember it. And the best way to do it, maybe look up the quadratic formula song and find some version of it, and it'll be stuck in your head forever. So it's x equals negative b plus or minus the square root. Let's try that again. The square root of b squared minus 4ac all over 2a. Putting it on my whiteboard. Yeah, this is a good thing to put in your notes for to know is the quadratic formula. And try to memorize it just, any means necessary, the song if you want to like burn it in your brain. The song is pretty helpful for this. So what are A, B, and C? A is the number that's in front of x squared. In this case, we don't have a number in front of it, which means it's 1, right? It's an invisible 1. So A is equal to 1. B is going to be equal to the number in front of x. And in this case, that's minus 3. Don't forget the minus signs. And then finally, C is equal to the number by itself. In this case, that's minus 28. So it's just in order. When you go from x squared to x to the number by itself, just going down with the exponents, A is x squared, B is x, C is by itself. So the way we use a formula is we just rewrite it, but instead of each letter, we replace the letter with the number that it stands for. So instead of negative b, we're going to have negative b, which is negative 3. So we have negative 3. Two negatives make a positive, so I'm just going to write positive 3, if that's okay with you all. So plus or minus the square root of, and now we have b squared. So b is equal to minus 3. So we have minus 3 squared. I'm just putting it in parentheses because it's just to show that the minus is also being impacted by the squared. I think technically if you didn't have the parentheses, then it would the minus sign would not be part of it. Teach me the law of sines and cosines. So that's like a trig thing. I can go over that after this problem. Yeah, I don't remember the formula exactly actually. I'll look it up. I'll see what I can do. Okay, so minus 4 times A is 1, and C is negative 28. So we're going to get some slightly big numbers here, it looks like. And that's going to be all over 2 times A, which is 1. So it's kind of just brute forcing it. It's a lot of steps. You just kind of simplify this down until we get to just our two answers. So the 3 plus or minus is going to stay the same. Let's simplify what we've got going on inside of the square root. So negative 3 squared, that's negative 3 times negative 3. So 3 times 3 is 9. And two negatives make a positive, so positive 9. And then we have minus, now we have 4, minus 4 times 1 times negative 28. The 1's not doing anything. Anything times 1 is itself. And 4 times 28. Let's go ahead and put this in our calculators. That is 112. And you'll notice we actually have two minus signs. We have a minus sign here. We have a minus sign here. Two negatives make a positive, so it's going to be plus 112. That's going to be over 2 times 1, which is 2. And now let's keep simplifying this. So 3 plus or minus the square root of 9 plus 112, that is 121 over 2. Now simplifying this even more, what's the square root of 121? Well, a square root is just one number you have to multiply by itself to get 121. And you could put that in your calculator if you wanted, or you might know that it's 11. 11 times 11 is 121. So 11 is the answer to that square root. So now, yeah, 11, that is the square root of 121. So now, why am I drawing random lines? Here we have a plus or minus, and that actually means that it's going to be both, because remember that the quadratic has two answers. So we're going to have one answer where this is a plus and another answer where this is a minus. So let's actually split this up. Oh, I'm going kind of off the screen. Let's, we'll make it work. We'll make it work. Let's split this up into 3 plus 11 over 2 and 3 minus 11 over 2. Hopefully this makes sense. I know I'm going kind of all over the place, but I don't want to erase things in case anyone's still taking notes. So 3 plus 11 is 14. And remember that fractions are the same thing as division. That's an important thing to know. So 14 over 2 is the same as 14 divided by 2, which is 7. So 7 is one of our answers. And that's actually the same as what we had before. Then over here we have 3 minus 11. So think of it as money. You got $3 and then lost 11. So you're down $8 over 2. And oh, I'm going off the screen almost. 8 divided by 2 is 4. And 1 minus sign, so the minus sign stays. We just made it. So negative 4 is the other answer. So these are two answers, 7 and negative 4. So that's how you use the quadratic formula. It's very much just plugging in numbers and just trying it out. Now, I think I can go over no problem. I think I can go over the law of sines and cosines as well. It's going to be kind of the same thing, actually, because it's just a formula, I believe. But I don't remember what it is. So let's look this up. Okay, let's just start with the law. Oh yeah, I remember this. Kind of. It's been a while since I did trig. Okay, so it looks like the law of sines, and let's see, when the answer is found through the quadratic equation, do the signs of the answer still need to be flipped? I would suggest don't think of it as flipping the signs. Like, I know I said that like as a shortcut, you could just be like, okay, take your answers and then flip the signs. Uh, yeah, the x minus 7 times x plus 4 thing is just for factoring. That's how you factor it. The quadratic formula, you're completely bypassing the factoring thing. We're not factoring it at all. We're just going straight to this. So the x plus 7, x minus 4, and then like, flip the signs and stuff, that's just for factoring. So you don't have to do that with this. But honestly, with factoring, I would recommend probably not thinking of it as flip the signs after it at the end, because then you might accidentally do it twice or something. Just think of it as you take your factored form, you split it up into two equations, and then you solve each one. I know that's kind of tedious and takes longer, but I would recommend thinking of it like that to avoid making mistakes because it's easy to like overlook things, and that's one of the things you have to be careful about when using shortcuts is they're definitely faster, but it's easier to mess up. So just kind of advice there, but you can do it how you want. But yeah, the whole changing the sign thing is only for factoring. You should get the same answer both methods though. And then you could have even done this with completing the square as well, if you wanted to. I have a video about that if you're interested. Okay. So it looks like law of sines, and I haven't done this in a while, so I'm probably not going to go too deep because I feel like I'm going to say something incorrect. But it's basically where you have a triangle and the different, like if each side of the triangle is A, B, and C, I'll just draw it for you. I'm drawing what I just Googled for you. So here's a triangle, uh, A, B, and C, and then oh yeah, okay, I remember this. And then the angles are always the opposite letter. So B is opposite of side B and so on. When B is an even number. Uh yeah, oh yeah, because I think if it's an odd number, then you get like fractions. Yeah, because yeah, like if for example if it's three, you have to like divide it by two, and then it's like 3/2. And then you square that, it's like 9/4. No one wants to deal with that. So yeah, that is a good tip. I honestly don't do completing the square like at all. If I had the choice, I'm gonna factor if it works, and quadratic formula if it doesn't. That's kind of my go-to. Okay, so law of sines is it just disappeared. Okay, so A over the sine of A is equal to B over the sine of B, which is equal to C over the sine of C. So yeah, I believe it's just you plug in amounts. So like if you had 30 degrees for A and then 5 for A, and then let's say that B is 10, and then it's find this angle, then you could ignore the C parts because we're not using C and just plug in what we know. So we know the side A is equal to 5 over the sine of angle A, which is 30 degrees, is equal to B, which is 10. The lowercase letters are the sides, and the uppercase letters are the angles. That's important. And that's over the sine of B, which is what we're looking for. And then it's just an algebra problem. You just solve for the letter B here. So you can do the algebra trick, which is cross multiplying. So that is where you multiply when you have two fractions equal to each other. So even if you're not taking trig, even if you're like, I don't even know what it is you're talking about right now, this is important to know even if you're taking algebra is cross multiplying. So when two fractions are equal to each other, then you draw an x. And the points that are the things that are pointing to each other are multiplied together. So 5 is going to be multiplied to the sine of b. And the 10 is going to be multiplied to the sine of 30 degrees. Now this is being multiplied, so we can do the opposite of multiplication, which is division, and divide 5 on both sides. These cancel out. On the left side, we just have sine of b, and on the right side, we have 10 divided by 5, which is 2. And the sine of 30, if we use our unit circle, I'm sorry, if you're doing algebra, you might not have learned this, but some of you might have. I don't know if they usually go over this in algebra. Some of you might have learned this. If you have, then this is important, the unit circle. So this is 0. This is 90 degrees. I'm making sure I'm doing this right. Yeah, 180, 270. So 30 degrees is not that far. It's only going to be up to here. And I, I believe that, I don't know, it's been too long. Sine is the up and down. So this right here, I shouldn't have, yeah, 0.5. I believe, yeah, I'm pretty sure it's one half. Yeah, it's going to be one half. And then this right here is, I think it's the square root of 2 over 2, or square root of 3 over 2. Square root of 2 over 2 is the one in the middle, I think. Yeah, this is one half. This is square root of 2 over 2. Square root of 3 over 2. Someone correct me if I'm wrong. I believe that's what it is. Okay. So let's move this up here. So we know that the sine of 30 is one half. Whoa, what did I just do? 2 times one half. 2 times one half is 1. And now we actually have to do an inverse sine to get b by itself. So that is a sine to the -1. If we do that on both sides, then this is just like algebra where you have to do the opposite of what it is we're getting rid of. We want to get rid of the sine. The opposite of that is an inverse sine, and that cancels out the inverse sine and the sine, I believe. I It's been a while since I've done this, so I'm sorry if this isn't making a ton of sense. And then sine -1 of 1. So that is where it was. I think you might just have to use a calculator for this. Uh, sine h, I think, is the same thing as the inverse sine. It's going to give us 1.175, etc. B equals 90. But yeah, okay. So that, but I believe that's in, oh, right. Because it's not going to be in degrees, it would be in radians. Anyway, yeah, I'm sorry if this didn't make much sense. I shouldn't have attempted this because it's been a while. Uh, I was thinking maybe I could do trig videos at some point. I don't know. I'm not sure. Because for some reason, the regular math tutorials, I feel like they don't really do that well on YouTube. Normally, the test prep ones do better. So that's why in radians, yeah, it would be in radians, not in degrees. At least for like the sine and the inverse sine things. It actually depends on, I think it depends on your calculator setting. Because I know that the calculators, you can set it to degrees or you can set it to radians. But yeah, essentially, the law of sines and the law of cosines are both just going to be formulas that you just plug in and then you solve for the variable that you're looking for. Okay, I hope that helped. I'm sorry if it didn't because it's been a while. Uh, but yeah, we might just have one more algebra problem, maybe two more. I don't know. We'll see. We'll see where we go. Okay, we already did the exponent one. Did I forget to update the number at some point? I don't know. Doesn't matter. Because we did this. Oh, I haven't done the square root one yet. Okay, let's do the square root. X minus 3. This is a pretty important one, I would say. Okay, so we need to solve for x, but x is trapped inside the square root. So yeah, I'm glad it helped. I tried my best. So we're going to solve for x just the same way as before. We want to get x by itself. It's trapped inside of a square root. And the way we get rid of a square root is we square both sides because square root and squared are opposites. The problem is that if we square everything, it's going to be super complicated. Like if we squared this, we would have to do a bunch of like FOIL and other nonsense. So instead, what we can do is we can take this square root and try to get it by itself. Let's pretend that this whole square root is just a letter. It's a variable, and try to get it by itself. And remember that I like to do multiplication, or I like to do addition and subtraction first. So let's get rid of the plus one by doing minus one on both sides. So these cancel out. On the left side, we have 2 times the square root of x minus 3. And on the right side, we have 5 minus 1, which is 4. Now let's get rid of the multiplication. Remember, we're treating this square root as if it was a variable, as if it was just a letter. So the opposite of multiplying by 2 is dividing by 2. So let's divide both sides by 2. So these cancel out. On the left side, we have the square root of x minus 3. And on the right, we have 4 divided by 2, which is 2. Okay, so what is the opposite of a square root? The opposite is squaring. So now that we have the square root by itself, we can square both sides. So like that. All right. So we have squared both sides. These cancel out. On the left side, we just have x minus 3. And on the right, we have 2 squared. 2 times 2 is 4. And now to just finalize getting x by itself, we do the opposite of minus 3, which is plus 3 on both sides. These cancel out. On the left side, we just have x. And on the right, we have 4 plus 3, which is 7. So here's the thing about square root equations, and this is important. Whenever you get an answer, x equals 7, that's probably the answer. But whenever we have a square root equation, when you square both sides, you can sometimes get fake answers. Sometimes you'll solve it and then get an answer and then realize that it wasn't even a correct answer. And it turns out there's no answers or no real answers. So what we have to do to check if 7 is the correct answer is we need to plug it back into the equation. Now, if you want to check your work on answers on any problem, then I would recommend doing this on every solve for x problem, because this is how you make sure that you got the answer correct. But whereas with those other ones, that's just to make sure that you didn't make a mistake. For this problem, for a square root problem, you have to do it because the answer, even if you did it completely correct, it might still not be a real answer. So just to make sure, let's plug in 7 back into our equation. We're going to rewrite the equation, but instead of x, we're going to put 7. And we're just going to see if it equals 5. So we have to replace the answer to the original equation. Yep. And you can do this to check your work on any problem. Like if you're taking your final exam and you have some extra time at the end, you can do this for some of the problems. Just plug it back in and make sure it works. You don't even have to go through this whole thing. You can just like imagine the number being there and make sure that it makes sense. So like, for example, if you got x equals 2, and then you went back here and you realized, oh, that's going to give me a negative square root. So just looking at it for a second, you can kind of sanity check your answer and see if it makes sense at all. So this thing in the square root, let's do that first. 7 minus 3 is 4. Everything else is going to stay the same. The square root of 4 is 2, because 2 times 2 is 4. 2 squared is 4. And everything else will stay the same. And then continuing to use PEMDAS, next is multiplication and division. 2 times 2 is 4. And 4 plus 1 is equal to 5. That is correct. So we have confirmed that 7 is our answer. Now, when you're doing square root equations, occasionally, sometimes you'll get like negative 5 equals 5. And that's how you know that it's not a real answer. If you come across that situation, then one of two things have happened. Either you did something wrong, which, I mean, maybe you did, but most of the time it's going to be because it's a fake answer. And that can happen sometimes. So in that case, you would just say there are no real solutions. Like I would just like look back and just quickly make sure you didn't make a mistake. But that's one of the annoying things. It's like about these problems. It's like, was it me or was it the problem? Like So you kind of have to figure out what happened. Okay, let's do one more problem. What do we have? Let's switch our obligatory number. There you go. Trying to figure out which one to do. Let's do, you know what? Let's do completing the square. I had this one as like an extra problem just in case, but I think that it's kind of important to know how to do because the other ones I have here are kind of just like random things that you might need to know, but you might not. But I think completing the square is very important for both Algebra 1 and Algebra 2. So let's go over it, right? So completing the square is another way to solve a quadratic equation. Factoring, quadratic formula, completing the square, they all give you the same answer. So the goal of completing the square, and basically it's kind of like a version of factoring. So I want you to imagine if we had x squared plus, I never learned how to do this either. Well, you're gonna learn today. We're gonna add some knowledge. Oh my gosh. Catherine, thank you so much. Wow. That's crazy. That's actually the first ever super chat on the channel. That's really cool. Can I give it a heart? There's a big heart. Does it let me do anything? Why won't? Oh, I'm not. I don't even know how to do this. I can give it a thumbs up, I guess. Thank you. No problem. Wow. Thank you so much. That's crazy. Yeah, let's get some more thumbs up. We've got 3 thumbs up. Let's collect some thumbs up. Thank you. Wow. I don't even know what to say. That's crazy. Yeah. Thank you so much. I really appreciate that. So, completing the square. So the goal of completing the square is to kind of have a magic factoring situation. So we go, let's imagine that we had x squared plus 8, oh my gosh, x squared plus 8x plus 16, right? If we were to factor this, then we could turn it into not 2 numbers that add up to 8 and multiply to 16. I'll just save you the headaches and just tell you that it's 4 and 4. 4 plus 4 is 8. 4 times 4 is 16. Now that would give you x plus 4 times x plus 4. And you could rewrite that as x plus 4 squared because squaring is just the same thing as multiplying by itself, right? So we basically, the idea here is to make our factoring easier. What if we just had a squared and then we can get rid of it by square rooting both sides? That would be a lot easier than splitting it up into 2 different equations. The only problem is it's pretty rare to have a situation where you can just perfectly factor it to make it a square. So instead, we can force it to be in that perfect situation. And the way that we do that is we figure out what number should be right here. The way I think the best way to do this, first of all, is going to be to get rid of this plus 12 here. You deserve, thank you. I really appreciate this. Like, this is, I was not expecting that. So you definitely blew my mind. Wow. Okay. So let's get rid of the plus 12. Let's do minus 12 on both sides, and I'll show you why we're doing that. So these cancel out. On the left, we have x squared plus 8x, and I'm going to leave this big open space here. And I'll show you why in a second. The more I keep saying that, the longer it takes for me to show you that. The zero is not doing anything, so it's just going to be minus 12. So now our question is, what number goes here? That is a big question. Well, this is another one of those formulas that you're just going to have to memorize, and I'm not going to bother explaining why it works this way because I don't know. But basically, we take this number here 8, the number next to x. You divide by 2 and then you square it. Divide by 2 and square it. You just have to remember that. So dividing by 2, 8 divided by 2 is 4, and then you square it. 4 squared is 4 multiplied by itself, which is 16. Whoa, another super chat. Uh, what currency is that? Well, can I like click on it and see? I can't. Well, thank you so much. I really appreciate that. I'm gonna give that a like as well. It's like tricking me. There's like a little heart. It feels like you should be able to click the heart. Oh wait, you can't. Hold on. Yes. Can I do it on the other one? There we go. Okay, I thought I was like being tricked by YouTube into thinking that I couldn't click it. It felt like a clickable button, but we did it. We figured it out. All right, well, thank you so much for the super chats, guys. That's really cool. All right, so 16 is the number that needs to go here. But remember that in algebra, we can't just throw in a number like plus 16 and be like, perfect. Because remember, in algebra, you have to do it to both sides. Yeah, no problem. Okay, so we're going to add 16 on the other side of the equation as well. What? Here we go. Erase. Okay, so let's go ahead and simplify this. Minus 12 plus 16, that's the same thing as 16 minus 12, which is 4. So let's just go ahead and erase that and replace it with 4, right? So now what we've done is we've forced the equation to be in our perfect factoring situation where our numbers are 4 and 4. 4 plus 4 is 8, 4 times 4 is 16. And we don't even need to write this out. You could write it out as x plus 4 times x plus 4, but that's just the same thing as x plus 4 squared. So we're just going to skip straight to that. That's the goal of completing the square. It's completing the square to get it into a square. So now let's just go ahead and square root both sides. How do you multiply radicals? You just multiply the insides. So if you had the square root of 5 times the square root of 10, that's just the square root of 50. You can just multiply the insides of the square roots. Just a little math trick that's important. It's good to know. And that also gets into like imaginary numbers and stuff, which I actually haven't gotten into on this stream, but maybe not on another stream, or you can go back to like the finals videos. I think I touch on imaginary numbers. If you think you're going to be tested on those, then that's a good thing to know. Okay, so the square root and the squared cancel. On the left, we just have x plus 4. And on the right, we have the square root of 4. Now, this is important. When you square root both sides of an equation, what you're really doing is plus or minus square rooting. So there have been a lot of times where like people will get confused because I'll say like, what's the square root of 4? And I'll be like, it's 2. And people will be like, isn't it plus or minus 2? And yeah, that is true. Because 2 times 2 is 4, negative 2 times negative 2 is also positive 4. But the square root symbol means we just take the positive answer, which is why we have to specify that we're actually plus or minus square rooting. It's one of those weird math things. Just remember that if you're square rooting both sides, you plus or minus square root. And the thing that can remind you of that is because remember that quadratics have 2 answers. So if you didn't put the plus or minus on there, then you would go and solve it. And once you realize you only have one answer, then you might say to yourself, oh, wait, why do I only have one answer? Aren't I supposed to have 2? And that's because you didn't put the plus or minus. So maybe that's a thing that can help you remember to put the plus or minus. So the square root of 4 is 2, because 2 times 2 is 4. So that's going to be plus or minus 2. And once again, just like our other methods of solving quadratic equations, we split this into 2 equations. We split it into one where we have plus 2, and another one where we have minus 2. Ta-da. Okay, so to get x by itself on the top one, the opposite of plus 4 is minus 4. So we'll do that on both sides. So these cancel out. On the left, we just have x. On the right, we have 2 minus 4, which is, think of it as money. You got $2 and then lost $4, so you're down 2. -2. That is one of our answers. The other one is x plus 4 equals a -2. So we'll subtract 4 on both sides, just like before. On the left, we just have x. And on the right, think of it as money. You lost $2 and then lost another $4. Pretty bad day. You've lost $6. So x is equal to -6. So those are the two answers to this quadratic equation. And I guess just as an example of checking your work, let's say I wanted to check -2. You can rewrite this top equation, but replace x with -2. And then just make sure, um, equals 0. There we go. And just make sure that it equals 0. -2 squared is 4, plus 8 times -2 is -16, plus 12. 4 minus 16 is -12, plus 12 is 0. I know I went kind of fast, but that's just the idea, is you want to plug in the number back into x and make sure that the equation's true. So if you're taking your final and you have some extra time at the end, this is what I recommend you do, at least for the solving for x problems. Any of them that you felt like you were unsure about, you can go back and do this. And this was guaranteed to tell you if you got the right answer or not. This is like super helpful if you feel like you didn't do a question correctly. And just as a little hack, um, for multiple choice questions, let's say like A is 2, B is 3, C is 4, D is 5. If you had no clue how to do a solving for X problem, you could just plug the numbers back into the equation for each one and see which one's correct. Just process of elimination. It would take longer, obviously, but it could help. And I know that on the SAT and ACT, they sometimes like to try to avoid having you do that by like saying, what is the sum of the two answers? So you like can't plug it back in. It would just say add the two answers together when you're done. So that's kind of rude, but something to think about. Okay, well, I think that's going to wrap up the stream for today. I hope that this helped you guys. It seemed like you guys were saying that it helped, so I'm glad to hear. Well, I'll keep this here in case anyone's looking. Uh, good luck on your finals, guys. If anyone has any other last minute questions, you can ask them. I'll be happy to answer them. I'm not in any rush or anything. But yeah, honestly, practice problems, watching other people do them, and then doing them yourself is probably the best way to study. You can like reread your notes. I have 2 full pages. Good. That's that's good to have. Because then you can look back on it and you can even like create your own problems. And then if you really want to go try hard mode, you can try to explain the problems to a friend. Uh, like try to explain it. This is like, step 5 once you've like done a lot of studying, once you feel like you have a grasp of the material, you can try to explain it as if you were teaching it to someone who hasn't ever heard of it before. Honestly, that is one of the best ways to prove that you understand something yourself. Just from my experience, especially like when I've studied for tests, not even just math, but like I remember in high school, there were like, I think it was like economics or something, but I would like quiz my friend. We would like write quiz questions and then try to quiz each other. Half of A4 paper. Nice. But yeah, just trying to explain a concept in your own words is the best way to prove that you understand it, in my opinion. So yeah. All right. I think that'll be all for today. Good luck on your finals, everybody. Or if you're taking the SAT or ACT and you're watching this, then good luck on that as well. And yeah, that'll be the next video. It's an ACT video, I believe. So yeah, it won't be problems. It'll be a little bit different. It'll be kind of just like strategies for studying. I actually talked about it a little bit already. Just, strategies like watching people do problems and doing it yourself. How can you be confident on camera? By putting yourself on camera anyway. Like literally, I'm still very like if you guys saw um when I'm recording the videos, I get like a sentence or two out at a time, and then I mess up, and then I have to read redo that sentence. Like it would be embarrassing to see how many times I have to, like, that's why there are so many cuts in the videos, is because every single time that was me not knowing what to say next. Like I think at a sentence at a time. But yeah, I always like hated those assignments for school where it was like, you got to record a 3 minute video of you doing this. I'm like, no, I hate being on camera. But it's just something you get used to. At some point, it's just like yapping to a camera, it just becomes natural. Um, yeah, so that's just kind of my take on it. It's just like math, math, you got to keep practicing, do practice problems, and then eventually you'll get used to it. And then same thing with, confidence. Are you going to college? Yeah, I am finishing up my third year of college right now. And I actually only have one more semester after this. So I'm almost done with college forever. All right. Well, thanks for watching, everybody, and good luck on your finals. I think that'll be all. I'm more helpful than you know. Thank you so much. And thank you for watching. Thank you for showing up and for taking the time to take notes, especially too. All right. Good night, everybody, and good luck on your final exams. Hopefully this works. I have a thanks for watching. There we go. Incredible. All right. Bye, everybody.